Here we are in the last video for section 4.2, and so we have two more theorems that we'll go through. One we'll just talk about the theorem, and the second one we will prove the theorem in one of the directions. All right, so suppose we have two sequences where the terms of the first sequence, S sub n, is less than or equal to the terms of the second sequence. Then if the first sequence, the one with the smaller terms, if that diverges to positive infinity, then the second sequence that has all values, all terms that are bigger than the first, that should also diverge to positive infinity. And then on the flip side, if the second sequence is diverging to negative infinity, right, so it has all these values that are larger, and those values that are larger are all going to negative infinity, then if S sub n has smaller values, then that should diverge towards negative infinity as well. All right, so that's our theorem 4.2.12. 4.2.13 says if we have a sequence of positive numbers, then this limit, it's going to converge to positive infinity if and only if the sequence of the reciprocals converges to 0. Right? So we are going to prove that in the forward direction. Right? And so let's suppose that the limit of S sub n is equal to positive infinity. Given epsilon, so what does this mean? That given epsilon bigger than 0, let's let m be some real number. Let's make that real number 1 over epsilon. Right? So it's 1 over epsilon. Then what do we know? Well, then we know that there exists a natural number n such that as long as little n is at least big N, because S sub n is diverging, towards positive infinity, we are now going to have we now have S sub n, those terms should be larger than m for any point where little n is bigger than big N. And we said that that was equal to 1 over epsilon. Now notice that this is a sequence of positive numbers, right? And so S sub n is a sequence of positive numbers. And so if we take the reciprocal, if we flip all of those, then we are going to get 1 over S sub n is less than 1 over epsilon. So 1 over S sub n is less than epsilon. Again, 1 over S sub n, that's going to be positive. And so this is going to imply that 1 over S sub n, so its absolute value it's exactly the same value. And if we were to subtract 0 from it, it's exactly the same value. But that should be less than epsilon. Right? Oh, and that looks a whole lot like our definition. And so this tells us one over S sub n, it is going to converge to 0. The reverse direction. So you might wonder, how do we prove the reverse direction? I would say that's a great question. And you should take some time to try to see how you would do that. It should be kind of similar, just starting with the other stuff. All right, that is it for section 4.2. Thanks, guys.